I will be discussing the problem longest common subsequence. The problem statement says that given two strings, text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, then return 0. A subsequence of a string is a new string generated from the original string with some characters, can be none, deleted without changing the relative order of the remaining characters. For example, ace is a subsequence of A, B, C, D, E. For a common subsequence of two strings is a subsequence that is common to both the strings. The approach that I took out, if I would approach this problem statement, would be first, I would need to check if text2 characters are present in text1. Relating it to the longest increasing subsequence, I have to check if the previous letter is smaller than the next element, then we move ahead of the loop. While I was actually figuring out while I was actually looking at the YouTube video of this problem statement, I actually figured out what is the kind of intuition the longest increasing subsequence and as well as the longest common subsequence hold. So basically, the longest increasing subsequence problem was saying that I need to compare the first element with the next elements. So it's like I don't need to update my counter again and again. I just need to make first element, compare it with second, then third, then so on. And then I need to figure out that longest increasing subsequence. The approach which is taken in while solving longest common subsequence is we are going to be solving it by 2D dynamic programming solution, where we need to check if the first letter in text2 is same as text1, then add 1 and move ahead to find the longest common subsequence. We need to find the 2D table, where whenever a match of the letter, we will create a 2D table for the text1 and text2. Whenever a match of the letter is found, we will move diagonally with the sub problem. And whenever there is no match of letter, we need to check two sub problems. We will check the positions adjacent and downward. Whenever we move diagonally, we know we can look at the remainder of both the strings. And then when we need to give a default value when the subproblem goes out of bound, we need to assign it to 0. This is how we will initialize the 2D matrix when starting this problem. And then for every value in the 2D matrix, we have to compute value of all the cells of characters present until the result we will return. This is the bottom-up dynamic programming solution, where the time complexity is n into m and the space complexity is big of n. And the pattern which is observed while solving this problem are, so first pattern is 2D DP on indices. Second is match where we take mismatch skip choices. Third is overlapping subproblems memoization. Fourth one is optimal substructure recursion. Fifth is grid navigation, right, down, diagonal. Sixth is subsequence pattern, skip allowed and then order is fixed. Seventh is two pointer comparison on two strings. Eighth is bottom up DP table filling. Ninth is alignment pattern, match mismatch scoring. The 10th is transform recursion, where we use the DP table top down to bottom up approach.